Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome. I'm Alison Stewart, the host of Cut the Crop, and today we're going to be talking about reducing variability in lime application from ground spreaders. And we're going to be talking to Allister Holmes, the FAR Technology Research and Extension Manager. Hello, Allister. Welcome.
Hi, Alison.
So before we start talking about sort of the way in which we're lime spreading, let's just talk about lime to begin with and why it's important.
Okay, well, most crops have a preferred pH range of the soil that they'll grow in. So a lot of crops, it's in the sort of 5.5 to 6.5 pH range. And a lot of New Zealand soils are naturally acidic, so they often sit a little lower than that in the pH, the low fives, even into the fours. And often farming practices that we're undertaking acidify soil, whether that be the cultivation and the mineralisation of nitrogen and the application particularly of urea acidify soil over time. So what we use to counter that and keep the lime and keep the pH in the optimal range is we apply agricultural lime, which is a alkali material, and it raises the pH in the soil into the desired range. We're lucky in New Zealand that we have a number of natural sources of limestone up and down the country, and so it tends to be milled, supplied to farm and spread through the fleet of ground spreaders that also spread fertilisers.
So, I mean, obviously the piece of work that you've been involved in came about because of observations that you had where you felt that the lime wasn't being sprayed in a uniform manner. Just tell us about what you saw and why that raised a little bit of a red flag.
Yeah, well, it's funny how it came about because for a long time of living in the upper North Island, we often have paddocks that have vastly different parent material. So at one end of the paddock you might have a volcanic soil which tends to have a very neutral pH, and at the other end you might have a soil which is predominantly a peat soil which is much more prone to becoming acid. And so the way we've generally dealt with that is we've taken a sample, the length of the paddock, chucked it in a bucket and got an average number which actually tells you nothing, and then apply the lime according to that. So what the initial aim was to measure the pH geospatially in a paddock and at different points in the paddock, and then tailor the application of lime according to the difference in the pH in the paddock. So we planned all this out, and we undertook trials at a couple of paddocks in South Canterbury. And when we went back and compared what we wanted to apply with what the truck actually applied as recorded by its onboard GPS and monitoring system, there was a great variation. And it was then that we started digging into why was there a variation, and we quickly realised that spreading lime was not as easy as you might think on the surface. I mean, we've all seen lime spreading where there's a great white cloud of material and a truck going up and down, and you assume that the spreadings are taking place, and it is, but on a finer resolution there's a lot of factors that can affect the uniform application of lime even before we can start considering the ability to apply it at variable rates across the paddock.
Yeah, so the variable rates was not targeted variable rates, it was random variable rates.
Yeah, I mean, we started off, I say to people, we started off trying to do a fine painting with a house brush. Yeah. And then we realised we had a house brush, and then we effectively wanted to understand how that house brush worked and do the best job we could with that. So we sort of stumbled on this issue by accident, and one of the biggest suppliers of ground spreading machinery to farmers and lime to farmers is Ravensdown. So we talked with Ravensdown, and that was when we decided to co-fund a piece of work investigating this.
So tell us about the work that was done and the outcome.
Yep. So growers will have seen Arable Extra number 125, and if they follow that through, it effectively tells the story of how we did the work. So what we did was we got a number of different ground spread trucks, and people will have seen there's obviously different companies running ground spread trucks, but they also run slightly different systems of applying lime. So I think all but one of the trucks in New Zealand have twin disc spreaders. So at the back of the truck they have two counter-rotating discs, and then the material is stored in a bin on the truck, and it's dragged either by a belt or a chain through an opening, dumped on those discs, and then spread from there. So it's a fairly straightforward process. And with products such as urea and DAP, which are a uniform size and density, it works reasonably well. What we did is we got 5 of these trucks together, we put lime in them, we laid out a whole series of catch trays to catch the actual lime that was spread across the paddock, and then drove the trucks while they were spreading across these catch trays, collected the material, weighed the material, and then actually size graded some of the material to understand the particle size spread of lime across the spreading width as well. So a fairly major piece of work undertaken by the team at Lincoln Agritech, and found some really interesting results.
So what kind of variability did you find?
Look, a huge rate of variability, and so what we discovered quite quickly is there's 3 types of variability that we're dealing with spreading lime through a twin disc spreader. The first one is, as the truck is driving down the paddock, the rate of lime delivered from the hopper to the discs has to be uniform, or else you're not going to be able to get a uniform rate. So we measured the output of that chain or that belt to the discs, and we found variation of major. And I'm just looking here, we had when we were aiming at 3,000 kilos per hectare, we were getting anywhere from 3,000 kilos per hectare to 6,000 kilos per hectare coming out of that belt. And anybody who's ever worked with lime will know it's a difficult material. It doesn't flow, it clumps, and it falls away in slabs, and so it gives a real problem. So that's a challenge. And if you've seen lime spreaders in paddocks, you'll see they often puff, and that's right, when that material hits the discs and suddenly there's a massive burst of fine material puffing into the paddock. The second variability we measured was the mass of material at a distance from the truck. So generally the truck will spread in a bell-shaped curve, so there'll be more material in the centre of the truck, and then further away from the truck it'll taper off. And the way we generally counter this is overlap the passes, so that you try to get as flat a profile across the paddock as possible. And with granular fertilisers, most operators are using 12 metre belt widths, and they have carried those 12 metre belt widths. And that by belt width, I'm saying the truck drives down the first part of the paddock at 0 metres, turns around and comes back at 12 metres, and the overlap goes from there. But what we found was that was still giving a variation of nearly 100% in rate. And that could be changed by bringing the belt width down to 6 metres quite easily. So instead of driving every 12 metres, driving every 6 metres, you got a much more uniform application of material. And the third aspect of it that we measured that was kind of new, and not a lot of people had looked at this, was the particle size distribution, because the agricultural lime is produced using some pretty basic hammer mill technology, old machinery, massive range in particle size, anything from talcum powder through to 2 millimetre size particles. And inevitably the larger particles get thrown further from the truck because they can have more energy, and the lighter dust stays nearer to the middle of the truck. But what that also means is that the reactivity time of those particles is different. So if you have a fine lime particle with a lot of surface area, it will act on the acidity on the soil quickly, whereas a 2 millimetre large particle will act over a much slower time, and so you get a slower rate of change. And what we measured, unsurprisingly, was a massive variation in the proportion of fine particles and larger particles across the belt width, with very few large particles in the middle where the truck is, and very few fine particles at the outside of the spreading width as well.
So you've got this variability in where it's going and the size of the particles. How did that translate though into variability in the growth of the crop?
With that work, we didn't carry that through to the variability in the crop, and it actually highlighted another point that our team and other agronomists said, the optimal pH for growing barley is 6.2. And yet we couldn't find any work that had actually shown that this was the case in New Zealand. This was this assumption, but we hadn't had any work. So we didn't carry that through to that point, and it's certainly something we may look at doing, but we were really just looking at the uniformity of spreading. However, we know from crops that have had spreading undertaken of them that we can see ununiform or variable growth in crops following. In fact, one of the trial paddocks that we did in South Canterbury, even 2 years later, we could see a variation in the flowering of the clover seed crop that we mapped out with the GPS aligned identically to the passes of the lime spreader. And we had another grower who told us that he had a big problem with lodging in a ryegrass seed crop, and when he tracked it back, he realised the lodging was immediately where the lime spreader had been the previous year before. So effectively, something like soil pH is going to affect nutrient uptake. It's going to affect pests and diseases in particular, the different acidity of the crop. And in this case, he believed that the higher pH had resulted in more lush growth because of higher nutrient uptake that had then resulted in a lodging problem. So there's a whole range of downstream problems. We haven't measured that.
So you've got the level of variability that you've found. When you went back to talk to the lime spreading companies, were they aware of it, or was this something that was new to them?
I think New Zealand has a system called Spreadmark, and Spreadmark has proved to be a very good system at making sure that the product that's being supplied under the FERTQual branding is of suitable quality, and the Spreadmark certified trucks. Spreadmark certified for spreading 3 products to a certain standard, and that's great. But what the layperson, and I was one of them, I assumed that if a truck was Spreadmark certified, it was Spreadmark certified for all the products it spread. But in actual fact, it's generally spread for urea, DAP, and probably MAP or something like that. When I last checked, there were 7 trucks in New Zealand certified for spreading lime under the Spreadmark certification scheme. So that showed to me that they hadn't put the effort into it. But when I talked to them, they all knew the variability was high. And they said, and this is a fundamental problem, is the spreaders said, well, if the product was right, we could spread it perfectly. And so you can think, well, why don't we turn it into prills? We can turn it into 2 millimetre prills. We could, but it will increase the product price by about 10 times rather. And also, if the industry decided we wanted that, we just don't have the ability to produce them. So the spreading industry have actually been great about it. I mean, initially there was a bit of pushback about it. But when we went out with our information to growers, we said, look, if you want your lime spread, tell your spreader how you want it spread. And if that means that you want them to do 6 metre runs, not 12 metre runs, tell them that. But you're going to have to be willing to pay extra for it. I mean, obviously, if a truck's driving up and down twice as many times in a paddock, there's a cost there. And I think, talking with a few ground spreader operators, it tends to be about a 50% increase, because obviously there's fixed costs with getting the truck to the paddock and loading the truck, rather than doing that. So it does make things slower, a little bit slower spreading in the paddock, but you get a much more uniform job. So actually I was quite nervous about how the ground spreaders would receive it, but they've embraced it. But it's a classic case of what the consumer wants. So I encourage people to tell the spreader what they want.
And it comes back to that situation that, yes, there's variability, but return on investment, how much will it cost you to reduce the variability, and is there an actual benefit in yield that comes out of that?
Yes, well that's right, and as I said before, that's not something we've measured greatly, but it's certainly something that we possibly could investigate. But if people are going to put lime on, I think they certainly need to put it on correctly, because otherwise what they're going to be doing is adding to the variability of the paddock rather than minimising it. And so on that end, we encourage people to apply a slower rate of lime and apply it more regularly, rather than, if there's a tax problem, applying lime before the end of the financial year, which is something that has happened in the past. Because if you apply 5 tonnes per hectare and you have an uneven spread, you're going to have parts of the paddock getting 10 tonnes per hectare and parts getting 2. Whereas if you applied 3 lots of 1.5 tonnes per hectare, chances are over 3 different applications it'll become more uniform application. So that's certainly an encouragement there.
And in isolation, that absolutely makes sense. But, we were just talking to Richard Chenoweth about nitrogen applications, and he was sort of saying that sometimes it's better to put on a little bit more often.
Yes.
And if suddenly all of the best management practices means that the grower has to have, 5 times more, tractors moving up and down the paddock, then suddenly your environmental footprint, your carbon footprint goes through the window.
Yes.
So there's all of these, sort of balance factors that growers are going to have to take.
Yeah, absolutely, and it certainly is a challenge. And when I went to the National Farm Machinery in the States in February, I looked for better lime spreading technology, and there's a few lime spreaders out there that do a better job. They're effectively a trailed machine, massive hopper, and they'll either have a pneumatic boom that blows lime out, or augers or belts that carry it out. So there is technology out there that will give a more uniform spread of lime. The challenge is it's $200,000, and that's a capital cost that not many growers can bear. Now, whether there's an opportunity for a group of large growers to go in together and get one, I think it's an opportunity. But I don't think the ground spreaders are likely to get a dedicated lime spreader rig.
It's not
in their business model. Exactly. So it's something to be aware of. I mean, liquid lime is another possibility, but it's a difficult product to deal with. Very difficult. It's hard on pumps. It's hard on spray nozzles, etc. So different challenges there.
Nothing is ever straightforward in black and white, isn't it? There's always shades of grey, and there's always compromises, and it's just balancing up the pros and cons.
Yeah, absolutely. But I think, if I had to say, the key take-home message here is understand the lime requirements of your paddock, talk to your ground spread operator, and bring that belt width down to 6 metres. And if that's all you do, that will make a huge make your lime application hugely more uniform than if you don't do that.
Yeah, excellent. Thank you very much, Allister.
Okay, thank you, Alison.
Good pieces of good practical advice there. So thank you very much, listeners, and have a good day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.